Hello again. Welcome back to Algebra 2 Notes with Miss Faust. This is lesson 3.6.5, and what we're going to look at today is how we divide polynomials. So last time we looked at adding, subtracting, and multiplying. Now we're just moving on to the next step, which is division. So first of all, the thing to think about is that factoring is a simple way of dividing polynomials. So if you have something like x squared plus 5x plus 6, and you wanted to divide that by, say, x plus 2, what you're really looking at then is you're looking at x plus 2 times something else that gives you back x squared plus 5x plus 6. Right, because division is undoing multiplication. So whatever this is equal to is going to be the same thing that goes in that set of parentheses. So this answer to the division problem is the same thing that would fit right here. So if we think about that, if we look at the second part, we can think of two things that multiply to 6 and add to 5. Hopefully you can think of 2 and 3. So we already have the x plus 2, so this would be x plus 3. So we also know then that x squared plus 5x plus 6 divided by x plus 2 equals x plus 3. So you have done some division of polynomials before, we just haven't called it that. And the thing is, we can't always factor. So if we don't have an x squared term in front, if we have a higher polynomial, then we're going to have to do something more with these in order to do our division. So what we look at then is what we call long division of polynomials. And this is very similar to long division of numbers. I know some of you learned long division in elementary school, some of you didn't. We did a little bit of it in class last time just to sort of give you an overview. Hopefully you can take those ideas and start to apply them here to the polynomials. And if you didn't understand it with numbers, you might still get it with polynomials. Lots of times people are like, oh, now I kind of get it. So be patient with yourself, and I think that you will figure it out. So example 1. And what I'm going to try to do is go through the example first, and then I'll give you the steps. Sometimes it helps if you've seen it once. Then you just understand the steps a little bit better. So our first example, I can't find, of course, because that would be far too easy, but you're catching up anyway and writing things down and writing them down and writing them down. And oh, Miss Faust, what has happened? Okay, here's example 1. We have x cubed minus 3x squared plus 5x minus 3, and we're going to divide that by x minus 1. Okay, so what we want to do is we want to put this x minus 1 on the outside of our division box. X cubed minus 3x squared plus 5x minus 3. So just like with division of numbers, when you look at how many times the first number goes into the first term, we're going to do the same thing when we're dividing polynomials. So the first thing we're going to look at here is we're going to ask ourselves, how many times does x go into x to the third? Or another way to look at that, I just like to keep track of these sort of supplementary steps on the outside, is we think about what's x cubed divided by x. So my x cubed came from here, my x came from here. Well, x cubed divided by x, so 3 minus 1 is x squared. So that x squared is what I'm going to put on the top first. So first I divide. Then I take what I divided and now I multiply it, and I have to make sure I multiply it by both pieces of this. So I need to do x squared times x. That gives me x to the third, and then I need to do x squared times negative 1, which gives me negative x squared. And what I want to do now is I want to subtract this whole thing from what's right above it. So notice I'm lining up the terms, and since I'm going to subtract everything and I'm subtracting a polynomial, really what that means I want to do is I want to change the signs of both of those. So first we divide, then we multiply. change these signs. Now we're going to just combine like terms going up and down. X cubed minus x cubed is 0. That doesn't give you 0, you did something wrong, and you got to start over. You always should get 0 from that first part. Negative 3x squared plus x squared is negative 2x squared. So that's what I get when I combine those. And then I bring down my next term. So plus 5x. Now I'm going to look at x minus 1 dividing into this part. So I don't ever go back up to this. I always go to whatever I have left down here. So negative 2x squared divided by x. Well, that's negative 2x. Basically, my exponent's just going down by 1. So at the top now, I'm going to put minus 2x. So I divide it again. Then I multiply. Negative 2x times x is negative 2x squared. Negative 2x times 1 is, negative 2x times negative 1 is positive 2x. Again, I need to go through then. I need to change the signs because these things have to be subtracted from these. So this becomes a plus. This becomes a minus. So negative 2x squared and 2x squared is 0. Again, that should always be 0 or you did something wrong. 5 minus 2 gives me a 3x here. 5 minus 2 is 3. And then I bring down that last minus 3. So then I say to myself, okay, how many times does x go into 3x? Well, 3x divided by x is just 3. So my number on the top is going to be a plus 3. I multiply. 3 times x is 3x. 3 times negative 1 is negative 3. I change the signs, remember, because if we try to subtract these now, we wouldn't get zeros. So I change that to a minus and that to a plus. 0 and 0, that's a good thing. That means I have no remainder. This answer on top then is the answer to this problem. So let me find a different color. So this divided by x minus 1 equals x squared minus 2x plus 3. Now, just like in other division, we won't always get zeros at the end, but I'll show you what happens when we come to one of those. For right now, this is just all we need to do. So this is our final answer. Because we did over and over again, so for example 3, we're going to do 2x to the third minus 10x squared plus x minus 5 divided by x minus 5. And just so you know, we won't always have just x's and numbers over here. I'm starting off with those so you start to get the idea, and then in class next time we'll look at some more complicated examples. Also here, notice our exponents are going down by 1 each time, 3, 2, 1, 0. If that wasn't the case, like if this didn't have an x squared term in it, when we write out the division problem, we'd have to write 0x squared in that space, because you have to, when you write the division problem, you have to have a space for each exponent inside this box. We have them all here. I'll show you an example of that in class next time. Again, I can't show you every example in one short little video, so just to get the basic idea is what we're doing here. So first divide. Remember, we divide the outside terms, so 2x to the third minus x. 2x to the third minus x is 2x squared. So on the top here, I put a 2x squared. Then I multiply. 2x squared times x is 2x to the third. 2x squared times negative 5 is negative 10x squared. Draw the line, change the sign. That gives me a 0. Negative 10x squared and 10x squared gives me another 0. So this is an interesting case, right? Because we have 2 zeros there. So we could now bring down the x, look at how many times x goes into 0, or 0 is divided by x. We could do the same thing, or since we have no terms now and we need 2, the easier thing to do is just bring down the next 2 terms. Either way, if you go through the process again, you would still get x minus 5 in the next step, but it just saves you a little bit of time and energy because you have 0 there, but we still need to have 2 terms because we had 2 terms up here to do our division. So now we do this x because these zeros really just go away. So really we're just dividing into x minus 5 now. So x divided by x, careful here, lots of people think that's 0. X divided by x is not 0, it's 1. So I need to put a plus 1 at the top. 1 times x is x. 1 times negative 5 is negative 5. I draw the line and change my signs. Good thing I do, because then when I combine them, I get 0 and 0. So I have no remainder in this one. So that means that the answer to this problem is 2x squared plus 1. So really, in this case, again, we have no remainder. We've found that these are both factors of 2x cubed minus 10x squared plus x minus 5. So that problem is equal to x minus 5 times 2x squared plus 1. We call this the factored form. And this should look similar to some of the polynomials that we were graphing. Remember, our goal here is to try to get from standard form back into factored form or intercept form, because then we can graph our polynomial. Graphing it from standard form is pretty obnoxious with all those terms in it, but graphing it from factored form or intercept form, as we saw the other day, is a lot easier. So that's why we do this, is to try to get back to this factored form.